Hello everyone. So myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video lecture, I am going to discuss about the interconnection of two-port networks when they are connected in series. Okay. So in this topic, we have to take the two-port networks. That two-port networks, they are connected in series. Okay. So here, we have to discuss the following things here. So interconnection of the two-port network when they are connected in series, and problems on the interconnection of the two-port network when they are connected in series. Okay. So here, explanation about the series circuit. So explanation about the interconnection of two-port network when they are connected in series, right? So in this case, I am taking the two-port networks. So here I need to draw the two-port networks. So here is the one two-port network and this is the another two-port network, right? So for this we are having the total voltage. For these two-port network, the total voltage are one dash port voltage is V1 and secondary voltage, that is 2 dash, second port voltage is V2, right? So now we are having the negative terminal is there and here also negative terminal is there. That means 2 dash is there and here also 2 is there. For the X network, this is I am representing as a X network, and also we are having the Y network. For the Y network we are having the input terminal, that is positive terminal for the primary side and for the secondary side. Now these two we have to connect it in series, means we have to connect these 2 points. Now here also we have to connect these 2 points. Now these X network and Y two-port network, now these two are connected in series combination, right? So now the input voltage are 1 dash port voltage is V1 and 2 dash port voltage is V2, right? Now here the total current I am taking as I1 and here the total current I am taking as I2. Now for the X network, the input current for the X network, the input current I am taking as I1X and input voltage I am taking as V1X, and similarly the secondary current I am taking as I2X, and for the X network the secondary voltage is V2X. Now the same I1 current is leaving here, so this current also I1X and here also leaving current I2X. This is for the X network. So for the X network, the input voltage is V1X, input current is I1X, and for the secondary side output voltage is V2X and the output current is I2X. Similarly for the Y two-port network, so for the Y two-port network I am taking input voltage as a V1Y and the output voltage as a V2Y. Now the input current of this Y network is I1Y and this is I2Y. Okay. So these are the parameters of the two-port networks when they are connected in series, right? So now for this series combination, series network, we have to write the current relations. After that we have to write the voltage relations, right? So here first of all the current relation. So here I1 is there and also here also I1X is there. So these two are same only because these two are in same line. So I1 equal to I1X. So the same current is flowing here. So here also I1X is there. This I1X is flowing here. Means I1X is nothing but I1Y. That is equal to I1Y. So first current relation. Now the second current relation is secondary side. So I2 equal to I2X. So I2 equal to I2x, that is equal to, here also I2x is there, this I2x is nothing but I2y, that is equal to I2y. So this is the current relation. So here let us take as equation number 1. Now for this X two-port network and for the Y two-port network, so we have to write in terms of the Z parameter. For the series combination circuit, we have to write in terms of the series combination. So here is the series combination. Z parameter equation is, so already we know the Z parameter, V1 equal to I1 Z11 plus I2 Z12 and V2 equal to I1 Z21 plus I2 Z22. So this is, let us take as 2 and this is, let us take as 3, right? Now you can see here positive terminal is there and here negative terminal is there. Now apply KVL in this loop. So this is one single loop. So this is one single loop. So apply KVL in this loop. So we'll get, so here apply KVL. So we'll get V1 equal to V1x plus V1y. So here plus V1 minus V1x minus V1y equal to 0. So after that we'll get V1 equal to V1x plus V1y. Similarly, apply KVL in this second loop. So we'll get V2 equal to V2x plus V2y. That means plus V2 minus V2x minus V2y equal to 0. Then V2 equal to V2x plus V2y. Now let us take as this is equation number 4 and this is equation number 5. Right? So now we are having the main Z parameter equations, and here when we are applying the, we'll get the input voltage of the input voltage V1 value and output voltage is V2 value is there. Now so now here we have to find out the V1x, V1y, V2x and V2y. So V1x is input voltage of the X network, V1y is input voltage of the Y network, V2x is output voltage of the X network, V2y is the output voltage of the Y network. So now here for the X two-port network, so now we have to write in terms of the Z parameter. So here for the X network, the input voltage V1x equal to I1x into Z11x plus I2x into Z12x. Similarly, V2x equal to I1x into Z21x plus I2x into Z22x. This is for the X network input voltage and output voltage, right? So here let us take as this is equation number 6 and this is equation number 7. This is for the X two-port network, right? Similarly, for the Y network, so for the Y network, Y network input voltage is V1y, output voltage is V2y. So here V1y equal to I1y into Z11y plus I2y into Z12y and V2y equal to I1y into Z21y plus I2y into Z22y. Now let us take as this is 8 and this is 9. Okay. So now what we need to do, Now we have to substitute equation number 6 and equation number 8 in equation number 4. So now here substitute equation 6, equation 8 in equation number 4. So here we are having the fourth equation, v1 equal to v1x. What is v1x? Equation number 6. So v1x is equal to I1x into z11x plus I2x into z12x plus v1y is there. What is v1y? Eighth equation. So I1y into z11y plus I2y into z12y. Then v1 equal to, here I1x is nothing but I1, I2x is nothing but I2, I1y is nothing but I1, I2y is nothing but I2. So in the place of I1x we have to write I1, in the place of I2x we have to write I2, right? So then v1 is equal to I1 z11x plus I2 z12x plus I1 z11y plus I2 z12y. Now v1 is equal to, so I1 z11x, I1 z11y. In this equation I1 is the common term. So then z11x plus z11y into I1 plus and I2 into z12x, I2 into z12y. So these two are also, in these two also I2 is the common term. So here z12x plus z12y into I2. So this is, let us take as equation number 10, right? So now, so this is v1 equation, equation number 10. Now we have to substitute equation number 7, equation number 9 in equation number 5. So now here substitute equation 7 and 9 in equation number 5. Okay, so here the fifth equation is v2 equal to, so v2 equal to v2x plus v2y. So already we know the v2x equation. So here what is v2x here? I1x z21x, I1x z21x plus I22x z22x, I2x z22x plus v2y. So what is v2y? So v2y is there. So I1y z21y. So I1y z21y plus I2y z22y. Right? So now I1x is nothing but I1, I2x is nothing but I2, I1y is nothing but I1, I2y is nothing but I2. So that is equal to, so I1 z21x plus I2 z22x plus I1 z21y plus I2 z22y. That is equal to, here I1 z21x, here I1 z21y. In this case I1 is the common term, means z21x plus z21y into I1 plus remaining term z22x plus z22y into I2. So let us take as, this is equation number 11. Now we have to compare the equations. We have to compare equation 10 and 11 with equation 2 and 3. So now we have to compare equation 10, 11 with equation 2 and 3. So now we'll get Z11 equal to, so here Z11 equal to Z11x plus Z11y. Z11x plus Z11y. Next, Z12 is there. So what is Z12? Z12x plus Z12y. So here Z12x plus Z12y. Similarly, Z21 equal to, so here also Z21x plus Z21y, and Z22 equal to Z22x plus Z22y. These are the Z parameters of the interconnection of the two-port network when they are connected in series. Okay, so this is the explanation about the interconnection of the two-port network when they are connected in series. Now, in the series circuit, we will discuss the one problem on this series connection, right? So here, so in this problem, so we have to calculate the Z parameters like Z11, Z12, Z21 and Z22. So here, let us take as this is X network and let us take this as Y network. So here Z11X equal to 2 ohm, Z22X equal to 3 ohm, Z21X or Z12X equal to 6 ohm. This is for the X network. Now for the Y network, Z11Y equal to 5, Z22Y equal to 12, Z21Y or Z12Y equal to 8. Now by using these equations, we have to calculate the Z parameters, that is Z11 equal to Z11X plus Z11Y, that equal to what is Z11X? 2 plus what is Z11Y? 5, that is equal to 7 ohm. So Z12 or Z2, okay. So here, so Z12 equal to Z12X plus Z12Y, that equal to what is Z12 here? Z12 equal to 6 plus Z12Y is 8, that equal to 14 ohm, and Z21 is equal to Z21X plus Z21Y equal to, so 6 again 6 plus 8, that is equal to 14 ohm, and Z22 equal to Z22X plus Z22Y, that is equal to, so Z22X is 3 plus 12, that is equal to 15 ohm. Now this equation write in a matrix form: Z11, Z12, Z21 and Z22, that is equal to, so Z11 is 7 ohm, this is 14 and this is also 14 ohm and this is 15 ohm. Here is the answer for the Z parameter when they are connected in series. Two two-port networks are connected in series combination. Thank you, one and all.